The definition of present value is the current value of a potential amount of money or source of cash flows given a fixed rate of return. The present value of future cash flow is reduced by the discount rate. The higher the discount rate, the lower the present value of future cash flows. It is an important financial concept, which is the money that we receive in future is not worth as money as an equal sum received today. For an example, RM 100 we receive 5 years from now is not worth as 100 received today. Why present value is important? It is because it helps investor to measure prices over time. Present value may assist investor in determining the potential financial gains of existing assets or liabilities. Investor can measure current value based on potential returns in fields such as financial modeling, portfolio valuation, and bond pricing. For example, if an investor wishes to compare two types of investment, he or she will compare their present value to see which one has the better returns. The higher the present value, the better the returns.
There are several formulas for calculate present value. As you can see here, there are 3 different formulas. However, we choose to use the easier formula, which is the formula number 1 and number 2, because it is easier to apply to the formula in the calculator and it is more simple to remember. For these two formulas, FV stands for future value or cash flow for future, and sometimes in the first formula, FV will replace with S, but it still means the same. Next, I stands for interest rate or discount rate, or it also can be as return rate. And the last one is N. It is for number of period in the future cash flow. To calculate net present value, there are 2 choices of formula, but the easiest formula is formula number 2. This formula is same as the formula number 2 that used to calculate present value, but the difference is we must minus initial investment here. So that's all for present value and net present value formula. Thank you.
Okay, the question is, find the present value of $1,000 due after 3 years if the interest rate is 9% compounded monthly. So the question asks us to find the present value for $1,000 after 3 years if the interest rate is 9% compounded monthly. So we will use this formula. And now we have to find what is S, what is R, and what is N. So the S is $1,000 and R is, so this is 9%, right? So 9 over 100 is 0.09 over 12, which is monthly, 12 months, and N is 3 years times 12. 12 is 12 months and we will get 36. So we put this into the formula, which is P equal to 1000 in bracket 0.09 over 12 plus 1, sorry I forgot, and negative 36, and we will get 764.15. So this is, so the conclusion is $764.15 must be invested at 9% compounded monthly to have $1,000 in 3 years. That's all.
Okay, next for net present value. What is the present value of all the cash inflows and cash outflows of the following project? The project expected to provide 4 years worth of benefits of nominally $400 per year and investment today of $1,000 to launch the project. Okay, the formula for net present value is cash flow divided by 1 plus I, the rate, and T, the times of the cash flow, and minus the initial investment. Or we can use the formula, we can use this net cash flow divided by 1 plus I times by T, the times of cash flow. Okay, the first step, what is the PV of a $400 benefit that we expect 1 year from now? And the cost of capital is 20%. 20% is the rate here for the I. Okay, the formula we use this CF. CF, the $400 divided by 1 plus 0.2, the rate, and power of 1 because for the 1 year. So we get $333. Okay, for the initial investment, we will minus later after we calculate all the present value. Okay, next, what is the present value of $400 benefit that we expect 2 years from now? Okay, for the present value, if we expect we want to get $400 benefit for next 2 years, so still $400 divided by 1 plus 0.2 power of 2 because 2 years, so we get $278. Okay, next, what is the present value of a $400 benefit that we expect 3 years from now? Okay, the company should, okay, first we use $400 divided by 1 plus 0.2 power of 3. Okay, we get $231. Okay, for the last two, expect $400 in the fourth year. Okay, still $400 divided by 1 plus 0.2 power of 4. So we get $193. For the next step, to find the net present value, okay, we sum all these for amount, we get $1,035. And next, we minus the initial investment, 1,000. So minus 1,000 initial investment, we get $35. So this is the net present value. As the net present value of this project is positive, then it is worth to pursue this project. But if it is negative, then it is not worth for the company pursuing this project.
Next, a debt of $5,000 due 5 years from now and $5,000 due 10 years from now is to be repaid by a payment of $2,000 in 2 years, a payment of $4,000 in 4 years, and a final payment at the end of 6 years. If the interest rate is 2.5% compounded annually, how much is the final payment?
As for the next question, we are going to find the final payment at the end of 6 years by going to use this formula. So firstly, we are going to find the present value of debt. So the debt for $5,000 due for 5 years and debt of $5,000 due for 10 years. We are going to add across to find the present value of debt.
So we get 8,325.26 cents. So next step, we are going to find present value of payment. As for the payment, we have $2,000 due in 2 years plus $4,000 due in 4 years and plus X due in 6 years. So we assume that the payment at the end of 6 years is X. So now we are going to find what is X. By adding across the total value of present value of payment, we get this is the final answer we get. And how to get the X by this. So now we are going to get X. As how we calculated before, we get that present value of payment is equals to present value of debt. So to get X, you have to So now we get the answer by X. The value of X is $3,244.63.
Okay, we move to the second example. A bank offers a saving account with a 3% annual interest rate compounded monthly. Alex wants to open a saving account and make one deposit now that will enable him to withdraw 700 to go on vacation 5 months from now and 2,000 for a deposit on rental apartment when he start working 20 months from now. How much money does Alex need to deposit now? So this is the formula for present value. Future value times 1 plus interest rate to the power of negative number of periods. Okay, first we calculate the present value for Alex to go to vacation. The future value here is 700 and the number of period is 5 months and the interest rate is 3%, which is 0.03 divided by 12 because it says compounded monthly. So we calculate the present value followed by this formula. 700 times 1 plus 0.03 divided by 12 to the power of negative 5. So we get 691 ringgit and 32 cents. Next, we calculate the present value for deposit on rental apartment. The future value here is 2,000. The number of period here is 20 months and the interest rate is the same, 0.03 divided by 12. So the present value here, 2,000 times 1 plus 0.03 divided by 12 to the power of negative 20, we get 1,902 ringgit and 58 cents. So the question here asks, how much money does Alex need to deposit now? So to find the amount of money that Alex need to deposit now, we just add the first present value with the second present value. So we will get 2,593 ringgit and 89 cents. Next, for the discussion, we do a comparison between the present value and the future value. First, current value of future cash flow. Present value is the value of an asset investment at the beginning of the period. Discounted value of future sums of money, which means inflation is taken into consideration. It involves both discount rate and interest rate, and it is more important for investors to decide upon whether to accept or reject a proposal.
As for the future value, value of future cash flow after a specific future period, value of an asset, investment at the end of the period that is being considered, nominal value of future sums of money, which is inflation is not taken into consideration, involves interest rate only, and lastly, shows the only future gains of an investment, so the importance for investment decision making is less.